Okay, so some words about indigo again. There are several indigo plants in the world, and there's only one molecule called indigotin. So what's different in between all these plants? All of them, they can be used as fresh material to be soaked to have the extraction of the pigment indigo, and very few can be used when dried. So that was very complicated for people having very small production in the past. So in fact, you see, for example, the Persicaria tinctoria, when dried, it is turning blue, oxidizing. So the indigo is already done in the plant. So the cellulose of the leaf being dyed, it's very difficult to undye and redissolve. So we cannot use dried leaves. Even for the Strobilanthes scusia, the Chinese indigo, even very, very saturated, but it is absolutely non-soluble. You have extremely difficult to resolve that. Okay, so that makes the thing impossible. So people use fresh leaves. This one is the indigo, Western Africa indigo vine, which is Phalaenopsis tinctoria. That's the same, it's turning blue. So about the western plant, the woad, it was not turning blue because there was a special preparation to do. It was necessary to crush the leaves when fresh, so the enzyme can meet each component of the leaf. The enzyme will act when crushing the leaves. So people were doing balls, so they were crushing everything together, so there was a reaction, enzymatic reaction, to develop the blue precursors. Indigofera tinctoria is different. If you dry it very, very carefully, it is still green. It is not turning blue. It would turn blue when put in water. But if you harvest this plant from very, very dried countries, you know, it's growing in Sahel, it's growing in half desertic area. So you pick them and dry them immediately at very dry air, and they stay green. If ever you crush them, of course, the reaction will be done, but you keep them, and then the enzyme will start to work at the moment you put it in water. So here is the powder of Indigofera tinctoria. That's interesting because actually it is sold for hair coloring. It is developed at quite big scale for cosmetic, because that's the only one that you can dry and use by just humidifying it. So here is a bowl of water, a beaker of water. So I will just present this quick experiment of just soaking the leaves and waiting for the enzyme to transform the liquid. You will see that by yourself. And then at the moment the enzyme is transforming, so the precursors of indigo are generated. So we can use the dried leaves as they are to get first solution. And in a short time, you will see, that's the easiest way of using the leaves, of course. You will see that gradually it will turn kind of greenish, different green, bluish green. And then it will be possible to add a little bit of lime, and then we will have the indigo solution, the indigo vat. But you might see that it is, from now, it is turning a bit more bluish than before. Just by putting the water, you allow the enzyme to work on the composition, and that's extremely simple and quick. So that's probably why indigo is the most popular crop for indigo production. Not only because of the content, not only because of the content it has, but also because it is extremely easy to use it. So, sorry, I lost. So I need some minutes, which is not too much. Maybe, I don't know if you see that at the camera, but it is turning kind of bluish here. Okay, so now, how can we convert this simple infusion to a dye pot? The most simple dye pot of the history, of course. We can just put a little bit of lime. So I will use the quick lime, industrial quick lime, which is limestone, burnt limestone, and that's it. And I need 5 minutes more, and then I will soak my silk to be dyed, and by a simple dipping, several dipping, I will be able to stain my silk and have kind of interesting simple dye. So I need this, I need water to rinse, and silk. So this is almost ready. That's an incredibly quick system. So we can understand why is it so popular. And then you can have the extraction and the dye almost at the same time, kind of simultaneous process. So I will use this piece of silk for the demo. So of course we have to wet the silk. So I will have to face a paradox. The protein of silk, when in contact with a basic solution, there's kind of exothermic reaction. So it's kind of increasing the temperature. So the indigo doesn't stick so good when the vat is hot. So we will stay at kind of medium temperature, so 40 degrees or big maximum, sometimes less, and then I wait for the powder, the plant powder, to be hydrated. I'm almost ready. So first you will see how is the precursor, what's looking like the precursor of the indigo tint. So it is not 100% done, but I'm expecting kind of turquoise shade or something. I'm not sure I'm totally ready, but that's interesting anyway. We have some old texts, Chinese texts, saying that in Guangzhou they were selling buckets of Persicaria tinctoria in all markets of the city, so people could buy the big buckets of fresh plant and have their fresh dye for the silk. So it was kind of turquoise. So this is not the Persicaria, so we can have kind of equivalent even with the dried leaves. I'm not sure I'm almost ready. Sometimes we need a little bit of silk lime together. Maybe it's starting. So I have to rinse, of course. I will rinse first. We will see something. No, I'm not 100% ready. But anyways, it is taking something. In a short time, we will be able to dye with. So actually it is just that ugly green. So I will have my second dip, and then I will add the lime. So some blue bubbles appear. It's just water, warm water, and leaf powder. And it is reacting because of the enzymatic process. And then when basic, if it is basic, it would plug on the protein nitrogenous termination of the silk. You know, silk has kind of nitrogenous part, and to to fix the indigo derivatives on it, it must be slightly alkaline. So for the moment I'm just charging, but it is still keeping green. But at some moment it will turn more blue if I add a little bit of lime. So you see, this is strange because this is coming gradually. It is not white anyways. You see, it is kind of being a little bit turquoise, which is from the color, changing color of the precursor. Now, small amount of lime in it. No need of big quantity, you know. It's just to be sure it is like bit alkaline. Could be also wood ash, so you can imagine under prehistoric conditions you just have an earth pot with some warm water, put in the ashes of the bonfire, and from time to time you take a little bit of ashes and put in together, and that's it. It is not a very big chemistry. So that's interesting. That's the reason why probably it was the most popular indigo crop, because you can have a very small garden, harvest your plants and dry them. So maybe 10 plants you dry and put in a pot, and then wait for it to grow again and have a second crop and third and fourth, and then when you have enough leaves, enough to fill a pot, you can prepare your dye stuff, your dye pot. So that's so easy. You don't need agriculture, you don't need to look after that to the wild. You just need, you see, it's coming gradually. Of course I have to rinse better, and so you see it is coming. So the next dip will be much better, but you see it is giving quite an interesting shade. More turquoise than the indigo people know. Sometimes, you know, in some Vietnam, old Vietnamese texts, they say that they make the indigo green, direct indigo green, they say. It is not really green, it's not really blue, but that's what they call indigo green. So I will dip it again and change my water. So the last dip will be a bit longer, of course. So with a handful of leaves, you will be maybe surprised that you can get quite an interesting color. With the minimum of chemistry, no reducing agent, nothing of that. Just, you know, it is already reduced in the plant. So just warm water, a pinch of this, and it's enough to dye. So you understand that we cannot call it fermentation, we cannot even call it reduction, because by the effect of the enzyme it's going out from the plant, just slightly basic to get the electrostatic affinity with the fiber. So the amine NH3 termination of the silk, it is kind of nitrogenous, so basic. So if you make the solution basic, so this one will act as a magnet and take the precursor of indigo tin. So sometimes it's kind of green, like the Vietnamese green, they say. So sometimes it's turquoise, and sometimes it's even more blue, depending on the patience you have, because this was just taking 10 minutes, 15. Okay, so let's have a look to this, because you see it's turning more saturated actually. Isn't it funny? We are just using a handful of leaves and we have something which is probably the very early style for dyeing, you know. because it will gradually darken and darken, and you will see that you can have something interesting with very, very poor means.
Very different color.
Yes, of course, of course. And then we can finish. When totally finished, I will eliminate the line, and then you will see that it is not a stupid dye. It is something, you see, quite interesting actually. You can put that here, you see, much better. So it's still a bit turquoise, okay? If you want it more blue, you have to start after 1 hour, for example, and then add a bit more lime. But I like to finish this piece. I've never seen this simple recipe to be published. Never seen anybody evocating that. But there's kind of evidence when manipulating those plants frequently that people made, Western people made it very, very complicated because they were not in touch with the living plant. They had their commercial extract, you know, the blue indigo, the stone, so they had to crush that, to rewash that, to prepare, to reduce, but they didn't have the already reduced product which is in the plant. So you dehydrate your leaves quickly, so you have the reduced precursor inside, and you put it in water. The enzyme is separating that clearly from the sugar, you know, the glucoside, and then inside you have the sugar and the indigo-containing together, so you just need a pinch of base. But the sugar comes from the plant, because the enzyme is separating all those guys. So that's interesting. It's not an exception. It is a kind of everything in one. And probably in the very early times, it was even much easier to pee in the pot, because then you have the alkaline together. Yes, that was very simple thing. Yeah, I have a handful of leaves, I pee in my pot, and I wait for a couple of minutes, and I have a beautiful indigo vase. So it's not complicated. I will not have this demo today. Yes, we make it super esoteric, you know. I'm not sure it was really esoteric. So sorry for this pragmatic explanation.
Nice.
So you see how interesting it is to get those kinds of shades. So maybe one more. It's interesting if you consider that nobody is talking about the enzymes, and enzyme is the crucial key for very good fastness for yellows, crucial key for very red shade from madder dyes, and a crucial key for very simple approach of the indigo blue from the raw material. So I would encourage you to be interested on enzymes, really. Okay, last dip. So remember, if you warm the pot too much, it will take far less. That's an exception, because for wool it is the opposite. You have to warm the pot better. So that's interesting to understand that. It's the same for tannin. You know, tannin on silk will not take very much if you heat the pot. Tannin will take more if you use the cold solution. That's very interesting, because we used to generalize, and sometimes it is not very helpful. So, okay, so my very last, and then you see a non-conventional approach, but then this is a complement of the traditional method. But here, we did use the enzyme to separate the precursor which is a glucoside plus the indoxyl. So the indican is inside. I will show you that at the board. So the indican is the indoxyl, so the reduced precursor, plus sugar. If you let the enzyme work, the enzyme will separate sugar and precursor, and then you add a pinch of lime, which will develop the dyeing system, and acting together with the genuine sugar of the plant, it will give the good reduction. That's extremely simple. I do not even have to add sugar because it's already in. Okay, so the last one, we can dye more in this part, but just to shorten the demo and to show you that it is not little. So that's my first result. Of course, I was extremely quick. If I was patient enough, I would have even better, but that's a good starting point to over dye with the tannin, for example, with the cut tannin to get good black, or that's good departure to get even more saturated blue. That could be a shiny blue or anything. But you see, first I want to dissolve it. It is extremely difficult because I have to undye the cellulose of the leaf. It's like if I take a blue jean and I want to have the extraction of the blue from my blue jean to get a dye pot. So it is not impossible. We don't say it is impossible. So now, there's a question frequently asked is that, okay, we have these these dried leaves of Persicaria. How can we dye with? So it seems that it's almost impossible because it is not soluble in water, because the cellulose of the plant is dyed actually with the genuine content. So the blue is appearing, so that makes the challenge even more difficult, apparently difficult, because I will show you. First, we need a solvent for this extraction to soften the cellulose of the leaves. This solvent is caustic potassium. We will make ours very easily. So I have this container here. I will put a funnel on it and then some cloth, and then I will put some wood ash. Any wood, ashes from any wood. That's the neighbor giving that. Of course, I did not ask the type of plant, the type of tree. It doesn't matter actually. We are doing kind of prehistoric reconstitution. Okay, so on that I put water, and then I will have the potash solution, you know, from the ash and from the pot we have the potash. That's the etymology. So this solution is interesting because it is slightly basic, but when in contact with lime, this has potassium carbonate in it, but when in contact with lime, it will give a caustic potassium, a small amount, of course a very small amount, but that's enough to soften the cellulose of the leaves, and then we will have the extraction of the indigo-tin. So extraction is not enough, because you remember that it must be reduced, and also it must be alkaline to fix on the fabric. So we will have those things together. Alkalinity will come from the mix we are preparing, and then we'll put those leaves to be softened in, and I will add a bit of sugar or any sweet matter just to improve the reduction, because in this mix I have nothing really to reduce correctly. Will not be enough sugar in these dried leaves actually, because they are not precursors, they are already oxidized, so well, the form is not suitable. So first I need to prepare my potash. And then very soon I will quit the funnel and I will put my leaves and maybe a bit more leaves. Okay, that's the moment, because they are not very strong actually.
What's the plant this time?
That's Persicaria tinctoria, the one you said. Okay, this is my solution of ashes, from ashes. Still doing well. Okay, so we have enough potassium carbonate. So now I will put my leaves in. There's kind of reaction already forming a little bit. Okay. Now I will have a little bit of lime. And then it will change gradually. You see it's turning super yellow. And then I'm expecting the leaves to go to the bottom. At the moment they are cooked enough, they are hydrated enough, they will go to the bottom. It's not already the case. And then at the moment we see the leaves to go to the bottom, it means they are hydrated. So the implication is that, of course, what was inside of the leaves is in the liquid. If it's still floating, it means we didn't extract enough. At the moment it will be just saturated of liquid, it will fall. So almost. It must not boil as crazy, although all that is not necessary. Must not wait for bacteria to come and reproduce and make plenty of babies to develop a civilization. No, it's not fermentation actually. It is just organic reduction. So now, I'm not sure you can see that, but the first blue bubbles appear. Very small amount, but it is a little bit bluish. So it will be developed even better after some minutes, but it's not immediate and they are still floating, you see. But then if I'm prudent and patient enough, I will have the good bubbles after a while. So better, the bubbles are better actually. Can you see the beautiful bubbles here?
Yeah,
you see the bubbles coming in the middle of the mess, in the middle of the sludge. So it takes some minutes for the leaves to be hydrated. but it's coming. So you see now other bubbles coming, and then I leave maybe 5 to 10 minutes for the leaves to start to go at the bottom. That's very important. Observing what you're doing. Observing. So now it's kind of a little bit of metallic coat. It means that some of the indigo is already reduced from the content of sugar which is in the plant, which is probably not enough. So I will add a pinch more, but first of all I will try to find a little piece of fabric to test it. So I need two things. I need patience and water. So I will look for the patience. So
but
quick.
It will be like 10 minutes. Better not cut and compress it so much, because it's a lot of information. 10 minutes, and then for rather in YouTube and in Facebook you give a link to your YouTube. So
1 minute more to show the result, maybe, or 10 seconds to show the result, or 5. Okay, so here we are. We have little blue bubbles. It starts to be a bit coppery at the surface, so I guess it is on the way. But the bubbles are pale. They are not very dark. They are not very big. They are blue, absolutely blue, but they are flat. I want a little mountain of bubbles, and then it is floating too much for that. So maybe I will try with more water, but it is still floating now. Sorry. So doesn't matter. I will start again, and I can see that it is improving. So this is time for testing. I will test with a small piece of fabric, sugar, so you will see. Imagine now I'm keen on my lovely silk, so I want to dye the silk in. What do you think? Is it possible? Well, we said if it's very hot, it will not take correctly. So I will start with a piece of cotton, and in case I have result, I will add the sugar, and I will be able to dye more of wool or cotton, but for the silk I will have to be patient enough to wait for it to cool, and at the moment it will cool correctly, maybe, well, not more than 30 degrees, I will be okay for the silk. But remember, the water is coming from the kettle. Okay, first test. Oh, it's doing something. Okay, let's rinse and see. We cannot say that there's nothing, but it is the very, very beginning of the system. But obviously we have something on the fiber, obviously. But it is not enough. So I have two possibilities. First, I want the sediment to go at the bottom. So I will increase the density of the preparation by having a bit of more lime. So, but by having more lime, you know, that's my method to avoid the liquid to float, the plants to float. We will see if it's enough, and then if it doesn't do the expected result, I will add the sugar immediately. No, it's too early. So doesn't matter. We can have the dye. Could be any fruit peel, any juice, or even wild plant. But I prefer, for this short demo, I prefer the fructose from the beet. But it's not a fatality, you know, you can change that. We had very beautiful things with apple juice recently. Okay, so let's see how it is now. It's coming better, but not as I would like. So it's coming. Obviously, it's coming. Even from a pinch of handful of leaves, I can have something. So now, a bit of reducing agent. that's my sugar. Okay, the bubbles are better. Bubbles are turning a bit bigger. So I think it's on the way, except it is floating too much, but anyways, I'm sure I will. Oh yes, I will have something. Okay, so 1 minute inside, or 2 or 3, and we will see. So from the dried leaves we can do something, but we need patience for the sediment to go at the bottom, not to float in between, because you see when rinsing we have plenty of leaves and it is not clean. So I prefer to be patient enough when cooking the leaves, waiting for them to go to the bottom, and then from that I will have a clean pot. You see now it is improving, so I will see how it is. Yes, yes. Yes, we have it actually. It's coming better. Yeah. So I will change my water and try again. We are at the very beginning of the vat, so normally with patience we will have it much better after some time. But you understand the system. We have to dye the leaves, the blue leaves must be discolored, and then the coloring matter must turn back to the dye pot. But I guess that now we can try, really. Okay, so some minutes and it's okay. So from any type of leaves you can have something. People are really in love of other fresh leaves. It's not forbidden, but there is a tradition, I told you, in Guangzhou during the 18th century, and probably even before, of course. But at the 18th century, the European travelers describe what they have seen there, so they are very astonished, because of course in Europe we don't dry with the fresh leaves of wood. We could do it, but nobody got that practice. Nobody wrote about this. It doesn't mean it didn't exist, but nobody wrote about this. And actually that giving fresh leaves are giving turquoise and silk, agreeable turquoise. You cannot saturate to be very dark, but it's quite interesting. And John Morris made a full book about that. So if you're interested, just have the book, take the book and follow the book. Personally, I prefer to try to get the really blue indigo, because this turquoise, when I started with that, I was a bit disappointed. It was kind of turning pale in a short time to the light. So it's not really the indigo. So that's the reason why probably nobody did write that as a recommended practice. So look at this. This is really reduced, right? Really strongly reduced. So if we rinse, it will turn blue, so greenish blue, and we will see. And it's coming, you see, but it's coming, but very slowly, because the leaves are still floating. I guess that in 1 hour or tomorrow, but you see the difference is quite important. Now, before we soak again, we have to wait for it to really oxidize, and maybe after 1 hour, at the moment it will be cooling, we will try the silk on it, a piece of silk, but the temperature is too high for silk. And you see it is kind of beginning of something, but it takes more. Okay, so that's the pose. The pose is needed to oxidize this, to cool a bit the pot, and then we will have it much better. Even with the cellulose, we tried sometimes almost boiling, simmering point of the vat. It did not take on cellulose, and sometimes it did undress the cellulose which was already dyed in blue. So you shouldn't exceed a limit, even for cellulose, which is 70, very, very exceptionally a bit more than 70. That's the super maximum. So, okay, we must be present. So I will soak it again and abandon it for a while. So we will find it better afterwards. No, everything is floating. I'm sorry. I'm sorry, we are too quick. It doesn't work. But the blue bubbles are here. Everything is here except that it is floating. Okay, so rendezvous in 1 hour, so it will be cooling.
Yeah, yeah.
Okay, so, okay, let's see how it is. So the reduction of these leaves, the vat of leaves, is not bad at all. We can see, okay, very good reduction. So it will give a good blue on the cotton. And now, despite it is a bit hot, I will like to try the silk. You see there's hardness color appearing, and it takes a bit more to be oxidized, but we can see that it is in progress. So now let's try that little piece of silk in the dried leaves vat. Of course, I'm sorry, I still have everything in one, but it doesn't matter. We will get an idea of how it is. So, during the while, you see that it is in progress. It is changing gradually to get the blue. So my first dip, oh, that's just turtle sauce, I'm sorry. It was not, it is still floating, I'm sorry. No, too hot for the silk. But you will see the silk beautiful anyways.
Well,
you see, that's a very, very simple method to get to that beautiful shade on silk. And by repeating, you will have it excellent. But that's the first step of silk dyeing with the leaves, you see. So I will have at least a second dip, and we will finish for today. We will wait for the vat to cool. It will be much better. And back to that, I will show how to oxidize a bit. But then now we will try to get a bit darker, but even a handful of leaves will give you something attractive.
So different shade from the previous one.
Oh yes, too late. But of course we can have different shades. And then about this, there's a little problem, which is too slow for oxidizing. So sometimes we can help with a bit of vinegar. So to eliminate the lime, so the oxidization is better. Maybe I still have vinegar somewhere. So vinegar here. So the yellowish shade which could come from the, the yellowish shade which is from the impurities or flavonoids of the leaves and everything together with the lime. This is disappearing, and now the blue is more honestly blue, I would say, like you see here. Okay. Okay, okay, last trial with the silk here. Of course, this is not rational. It is just a theoretical vat to show you that it works, and it could be some primitive thing that could be, but it is not rational to have the whole bunch of leaves together. So I will rinse that and it will be done for today. So you see, beautiful shade here. Of course, with that handful of leaves, we can have quite a lot of silk to be dyed in, because it is a super strong dye. So I guess that in the past, people just had small quantities, and then at industrial area, they started to import massively, but not the processes. They just imported the thing. So the Western people, they were embarrassed to use that. And sometimes when they say they were importing tons and tons of indigo, you might wonder, because there's probably less than 1 gram in that. It's probably maybe 10 centigrams. And even from that, you can have some activity. So we cannot even imagine tons. It's like billions of something, you know. But that's easy. So primitive sometimes is helpful to understand things and to get the idea of how to make it simple.